system clean and tight, every service running right. But in the dark behind the veil, a single point could make it fail. One database, all alone, no backup, fail over a clone. If it crashes, that's the show. Downtime's coming, revenue slow. One glitch away from disaster, one break and we fall faster. No redundancy, no grace, just an outage in your face. Let's fix what we can ignore. Resilience starts with one backup more. API gateway, just one node. Traffic chokes, can't share the load. Logs are silent, screens go black, all because we missed that crack. What's the cost of going blind? To spot UX we leave behind. $6,000 a minute, says the chart. Better build smart from the start. Cluster and balance and mirror your gear. Disaster strike fast, so engineer with fear. Out of your stack, trace every request. Redundant is good, it's how systems rest. One glitch away from disaster. Let's move from risk to master. With load balancers in place, we build with courage, not just grace. No more supposed to slow us down. High availability, where's the crown? Hey!
Hello everyone. So today we'll be starting going through all the concepts which are related to microservices, and I will be showing this with a hands-on coding. We'll be building a live application, and this will be the e-commerce application, and I will be going through step by step to complete this application, which will be the production ready application. So let's start. So give me a minute, let me place my project. So I'll be sharing the GitHub link in this particular session, so that you can also execute the code in parallel, or I would suggest you focus watching this session now and understand here my implementation, which is a full-fledged microservices application. It is a e-commerce application. It consists of various microservices, and there are total 7 microservices which are used to give the functionality of e-commerce application. So the first one is the catalog service. This is about products, managing products, storing details of the product like price, description of the product. Also it provides API services for other microservices like inventory and order shipment services, so that they can get the product details. Then I have inventory management service. This is a service to store the stocks, and in this service we will track real-time stock quantities of each of the product. This allows that we don't oversell. Then there is an ordering service which will take care of everything, which is post the checkout of a particular order. So we have user will first search the catalog, then he will use a shopping cart. So we have a service for shopping cart. So the items he wants to add, it will be placed in shopping cart, and then after shopping cart, once the order is checked out, order processing will take care. It will pass on, trigger the payment service. Payment service will connect to external payment provider, and once the payment is processed, it ensures reliability, fault tolerance, because it's a critical service. And then once payment is successful, we will be triggering the shipment service, which will take care of the delivery and tracking of the shipment for the product. So this is the entire flow for e-commerce application. We will be building, I will be demonstrating from coding how we can do it and what are the complexities which are involved. Microservices solves a lot of technical challenges which we face to build such a complex application, but some new challenges also comes in microservices, and in this session I'll be covering how we will deal with such challenges. And these challenges are related to remote service calls, because microservices connect with each other. They are autonomous, independent, and for all the communication which are usually done over Restful web services, there will be various overhead. For example, the network latency, performance overhead. So how to take care of that? Then we will also take care of various characteristics, how we can kind of manage them well. For example, a microservice should have RESTful interfaces. That's the first important criteria. Second thing is it should also have well documented APIs so that others, clients and other services can connect to it. So the contract should be well defined. Then we should also monitor the microservices for performance. We should have health checks in place. It should be fault tolerance if some communication is failing due to network problems. Sometimes the network is unreliable, so there should be retry. There should be asynchronous communication. There should be timeouts if service is down, other service is down. So we should build with reliability in mind. So I'll also cover some of the patterns. For example, circuit breaker, bulkhead patterns, which help us in ensuring reliability and maintainability. So don't worry if you are not able to understand this. For now, we will be covering them in detail as we proceed with the session. So let me show the microservice, and then let's start step by step, covering one concept at a time. This will help you understand it. So let me start with my first service. Just a minute. Let me also have some more So before I start, I'm just opening my content so that I can go through it in a structured way and it can help you understand. So let's start building our microservice. So I have a project here. I'll be sharing the repository as I mentioned. So first thing we have is a product catalog web service, and I will be demonstrating how to build this. So as you see here, there is a project, and this project is called MP e-commerce store. We will be using a framework which is called MicroProfile framework. And in this framework, we have all these characteristics or functionalities which are very critical for microservices, provided as APIs or sometimes even declarative APIs in the form of annotations. So this is our microservice. So I have this project structure. I'll be using Maven, and I am using a Java version. So let me start showing what is the environment. Let's get started. So I have a Java 17 installed. pom.xml is the configuration file which is used to build the project. So let me first go inside the project. So I'm going step by step, and this video you can use for reference, and once we cover this session you will understand A to Z all the concepts involved in microservices to make it production ready in enterprise class application. So if you have a very large scale application where you require a lot of scale, high availability, performance, the concepts which we will be discussing today, they will enable you to build such a microservice. So here this is my POM file. So here let me take you through what is there in the project. So my project is having a group ID. It is part of an official MicroProfile tutorial. MicroProfile is one of the latest framework for building Java based microservices in cloud native environment. So this is very much optimized for cloud, and our project name is MicroProfile e-commerce store. This is the short form for it. We're building a microservice. This will be in the var format, web archive. WAR it stands for web archive. We will be using Open Liberty Maven plugin. So Open Liberty is a server similar to Tomcat or any other server, for example Jetty. It provides a runtime for running Java microservices. I'm using this. This is also the reason is it is very modern. It is modular, lightweight, and very much optimized for building microservices. So let's start with other details. So we have here Java 17 configured. Then we will be running this microservice in 5050 port. Then the root, our context root will be microservice path. Root path will be this MP e-commerce store. Then we have here a Lombok dependency. This is for putting the boilerplate code for Java. I will demonstrate the usage of it. Then we will be using Java EE, or now it's called Jakarta EE, because we will be using JAX-RS. Now this is called Jakarta Restful web services. So our web services will be following JAX-RS standards, how to build integration test as well. And then this is our plugin to build our project, run the runtime, which is Open Liberty. Then we have Maven var plugin, and we have these plugins for running and reporting unit tests. So this is our POM. So we'll validate it so that we ensure that there is no syntax error. This is in the form of XML. So I will give the command mv and validate. Okay, first I have to go to the project directory. So I am going to the directory. I have checked out the code from my repository. So let me just share you the repository. So here you can see that I have I am in a branch which is called so this is my branch, and my Git project. Let me take you to the Git project. Yes. So the source code which I will be covering will be based on this particular Git project. This is the path. I'll share this, and in this we have various files. We have complete tutorial. Whatever I will be covering, this is already documented in the form of tutorial, and soon it will be available in a website as well. But right now this is available in the form of chapters, and there are various chapters you can go through on this. This is a public URL, and now you have code as well. So I'll be updating the code. Whatever I am covering will be updated in the code folder in this particular repository. So now coming back to our project. So now I have gone inside the code folder. This is I'm running from my branch, which I will be merging shortly. In the code project, I have a folder called chapter 1. So MicroProfile tutorial. Then I have chapter 2. So our coding will start from chapter 2. So the previous chapter is about introduction, which I just mentioned orally to all of you about the complexities of microservice, what is microservice, and what are the challenges there in building production grade microservices, and what is the example which we will be covering, which is MicroProfile e-commerce application. So let's start with chapter 2 of MicroProfile tutorial. We are building the source code and executing the source code, and this is very intuitive and easy to understand format, because for each of the project you will have a readme file as well, which has all the instructions about how to run this project, as well as important concepts which are required for this project are also explained here briefly. And definitely you can get in depth of these concepts by going through the corresponding chapter, which is chapter of MicroProfile tutorial. So now I'll give the command ambient validate. This will validate the pom.xml file store. So once I'm in the project folder, then when I see what all files are there, you see here this is the pom.xml file is there. So we have to validate this particular pom.xml file, which is the file which is used by Maven to build the project. So now I will run the command again. I'm using the environment which is called GitHub Codespaces. So this is a web-based IDE. That's why you are seeing this browser. But inside this we have Visual Studio Code, the web version running, and this is running on a Linux dev container, Linux based dev container, and that's why in terminal I'm giving various commands, which is more of a Linux command. And now I am executing this over there. So this is a very convenient platform. So ambient validate command will validate. So I see that build is successful. So next is I'll compile the source code. I'll go through the source code briefly. So we have a product class, because as I said, this is a catalog service. In the product class we have fields like ID, name, description, price. Then we have a resource class which is exposing this particular product class as a RESTful web service. So here, as you see, there is an annotation called data annotation. This is this annotation tells the preprocessor to run, to build, to attach the getters and setters method. So I have not provided any getters and setters method. This will be automatically generated by this library, which is called the Lombok library. And I will also be generating the constructor. So this makes the code very clean. So this is the purpose of Lombok. As we will be covering more annotations, I'll be telling them. But basically Lombok library is for making your source code clean, and it saves a lot of typing and makes the code very maintainable and readable. So this is very readable, simple, plain old Java class, Pojo class, which is product class. Now we have the RESTful web service class, which is product resource. In product resource, this is a bean, because this is a product web service, and it is having application scope. This is the scope of the bean. So this tells the container that this particular bean will be living for the entire application. Because it's a catalog service, it should be like a singleton object which should be running and always available for giving the list of product. I have here memory based catalog, so I'm not storing this in database for time being, because this is our first chapter, and here we will be covering one method which is get API, and which will give you the list of products. So this class does nothing, it just returns list of products. And this particular class, this is the constructor, and this constructor initializes the products, which is an array list, the dynamic array. And here we have the ID, which is the 1. We are using long as the type of the ID, so that's why we have product long value of 1. Then we have the name of the product, it's iPhone, description, and then the price. These are the details which we are storing. So this is all about our REST service, which is basically a GET service. And then I will have a application configuration where I don't have anything. I just have a path sharing that the have /API. This is the beginning of the path. So we have the context root, which is mentioned in the pom.xml. And then we have the API, then we have the resource. Resource is get resource, and this has path products. So the complete path of our REST API will be MP e-commerce store, because that's the context root, then /API/products. So now let me compile this particular source code. So I have to give the command mvn compile. Accidentally, while explaining, I added slash, so I remove that. Let me run this command again. Now it's compiling and build is successful. Now I will run this service in the debug mode or dev mode. So the command which I will need to run is mvn liberty dev. So this is listening to the debug port 777, so which we don't want to do now. So we can ignore that, but then this will run our microservice in the port which is 5050, which we specified. So yeah, we can go directly to 5050. As I'm using a cloud-based container, so there is a port forwarding in place. So here you can see here 5050 port is forwarded to a URL, which is this URL. This is the name of my container, and then this is running on cloud, and this is hosted on GitHub. So that's why you have this GitHub dev /5050 means that this is the port which is forwarded here. So now we got the Open Liberty server running. Now let me go to our context root, and as I said, this is the path of the REST API, and now we should get list of products. So here we have API and then the products. So let me come, we are in the debug mode. So application MB store is here, this is running, and let me see what is making it not to respond. So as such, no errors here. Okay, so it got stuck, so it's not yet fully built and packaged. So let me stop this for the time being and then run again. So let me say mvn clean. This will clean the product and project, it will clean the project and it will reinstall. So now I will give the command mvn liberty dev to run it in the debug mode. So these are all the forwarded floats, and then this is our so MP e-commerce API. Okay, so this is the correct path. Let me So I'm just going through reading about what is happening here. So here we have this particular project. Project is built successfully. Somehow the port is not visible. So let me forward a port. (5050) port is there, and our project. So we have a context route which we have defined here, which is MP e-commerce store. So we have the host name, then we have MP e-commerce store, then our REST service, okay, so I have got this removed by mistake. I will fix this. So you see here one line which was path while I was describing, this got missed. This was by X is last line which is removed, so no problem with this. Now since we are running on the dev mode, you see here automatically this will update the project source code, and let me try it without restarting the server. It should now return the list of products. So you see here we got the list of products. This is what we initialized our array list with. So this is a simple example which is about using JAX-RS based RESTful web service. So this is one of the project. Great. Now next, let's move to next exercise, which is we will be building more RESTful web services. So now we have built only the GET service. In the next exercise, we'll be building more RESTful web services. So let me stop this server. Control C is what I use to stop the server. You can also press Q to signal quit, and when you press Q in the keyboard, this will also stop the server if it's running in the dev mode. R will restart the server. So now I'm moving to another project which is part of chapter 3. So let me go to the root directory, then switch to the directory chapter 3. And then within this, I will come back to project, which is built upon further what we saw just now. And here we will be building more endpoints, REST endpoints. since this out, so there is sometimes some responsiveness issues. So let me now move to the, so I'm now inside the project directory. So let's show you the POM. It's exactly the same, no difference here. So next thing which is different will be the Java code. So here let's discuss a service. So let's open the entity class, which was the plain old Java class. So it's exactly the same. So here we have the data annotation. This will generate the getters and setters. We have no argument constructor. We have also created one more constructor, which is all argument constructor. So 2 constructors are created now. Then rest of the things are same. We have a resource class. Now if you see resource class has more methods. We are also using a service class, and then we are injecting service class using dependency injection. So this is something new concept which is introduced. So all your business logic is in the service class. This is layered architecture and makes the code very easy to maintain. So here we have the business logic, which is initializing a array list with 2 products. So this is very simple business logic. Then we have for this method get all products, it returns list of product, simple. And then we have get product by ID. So now more methods are there, and then we will be filtering products and then returning the product which has this particular ID which is passed in the argument. And this is an optional because the product may not be there, and so that's why we return optional. So here this is the business logic, and this is about creating a product, which is we add a product to the array list, and then we have here update product. Here we are updating the product with ID and the fields which are passed in the argument to this particular method. So here all the code which is so this is class which handles the REST protocol. It is technical class, and it has just delegation to product service. So what it does, it returns a response. So as you can see here, this will call the product service get all products method, and it will build the JSON response and it will return. So this is the various annotation. Produces annotation mentions that this will return JSON format, and if you want to return some other format, there is also classes available. So you can see here XML, various options are there. So based on what is the format of your response, you can use here some constant which will be corresponding to that particular format. So these are our get and post methods. So this is difference with the previous chapter. Now let me run the same commands in sequence. So the first command is mvn validate, which will be validating the product. So now POM is validated. We'll compile the source code. So this will check the Java source code for any compilation errors. Right, so once you compile, what we can do is we can say mvn clean cases which we have. So unit test can be executed to check whether we have everything running properly. So I have written unit test cases as well. all these unit test cases are executed and there is no failures. Now we can say ambient package. This will generate the package, which is a var web archive, which we can deploy in our server, and this will run the microservice. So now all the builds are successful. I'll run this particular application again in dev mode, so that in case something fails, we will get to know about the error in the console. Now we have the logging as well, so we can use logs as well to look into errors if it happens. So here the product REST application is initialized. So now let's see what is happening here. So again, the product service is running properly. Now we can also have we have product with ID 1 and product with ID 2. So we can pass as a path parameter an ID, and say for example if I passed I2, this will call get product by ID method, and it will filter my list and only show product which has ID 2. So for that we have to use some client like Postman, or we can use curl commands. Again, in this particular project I have provided a readme file, and in the readme file we have all the curl sample curl commands, so you don't have to define by yourself the curl command. They are ready-made available, so you can just copy paste and run it. It also describes the source code and changes which we have made, and it also describes the signature of our REST APIs. Now this is the post command to create a new product. We can copy here this command directly. Now once terminal is initialized, I can paste the curl command, so which I have done here. So this is it is post, and then it's calling the endpoint, and then this is passed in the header application JSON, and the JSON containing the new product details. So now I will run this command. So our new product should get created when I execute this command. This we can verify by again executing the get command in the browser. So now let me list all the products. This time we should get 3 products instead of 2. So you see here the third product is also created. Now we can also query by providing the ID 3 in the product. So you see here product ID 3. The details is displayed here. So now we can update this particular product also. So for example, let's say price has changed. So we can go to the command which is update command. So put is used to update the command. So yeah, here it's modifying the product, some other product, but let's say we want to modify this particular AirPods, then I will just replace this quickly. Okay, let's keep this because in command line it's little hard to update the JSON. Let me do this again here, easier. Yes, now I will copy here so that I can demonstrate the update of the new product. Now run it, and now let's see in the if this particular product is updated. So here the field value has been kept as 249.99. So here we should update this to some other value. So let me say here we'll make it 149. So there is $100 discount, good discount. Now let's see if this particular product has been updated. Okay, so this is, we updated by mistake the product ID 1. So here I should check product ID 1. It should have the price 149. Okay, so this is more than $1,000 discount. 1149 was the original price. Now 1149 became 149. So this is how you will update the product. Now let's delete this because yeah, this is not looking right. So this will demonstrate the third command, which is deleting a product. Delete syntax is exactly same as get syntax. So when I execute this product should get deleted. So now if I run this command again, let's see what happens. Product is not there. Now let me see if the list is there. What all is there in the list? So here, as you see here, this is product ID 2, product ID 3, product ID 1 is deleted. So this demonstrates the all CRUD operations which is described in chapter 3. Now another thing what I will also describe here is, here we have also implemented logging. So you see here we are getting message like exiting method, product resource, get all products, and execution time is 1 millisecond, because yes, this is reading from the array list. So everything is being recorded, even the response is getting recorded here in the form of logs. So this logging is also added in this particular project. And this is described here. The logging is, we have created an interceptor. In this interceptor, we have a code which will be defining a new annotation, which is logged annotation. And logging interceptor is the logic which has to be applied when this logged annotation is applied on any particular class or method. Because in the logged, we have these two targets. One is the type could be interface, class, enum, method. This is a method. So this particular logged annotation could be applied either to method or class. This is how you define an annotation, right? So you see here @interface. This shows that this is an annotation, and this is what is called. So we call this log method, which will be printing out all these details like entering method with parameters. So all the logic of logging is described here. So every method, when it exits, does some logging, and if some exception is thrown, then this particular messages are printed for, and as well as an entry and exit of the method. This is printed. So you don't have to put a lot of log statements for each of the methods. We can decouple this logic, put it separately in the form of logging interceptor. So this is applied to our sleeve. So you see here in the class level, this logged annotation is applied. This means that the entire class is logged, so all the methods within this class will be logged. So this is about the interceptor pattern. This is also another feature of Jakarta EE, and now we have demonstrated how to do logging. So we have used here Java util logging.logger because this is for demonstration purpose. In production you may use, for example, some other logging framework, log4j. This will provide you more flexibility. So now let me stop this service. This is everything which was there in this particular project. We have another project which is a catalog service handling coming up next. So let me just refresh this particular project so that it loads faster. Looks like, yeah, now it is. Sometimes Visual Studio Code, the web version becomes little bit slow because running on the browser, and browser sometimes takes a lot of resources. We have so many files open, so let me close these files also so that it is making our Visual Studio Code more responsive. Okay, now I go to the catalog. I will describe the project. So you see here we have various project classes. Now we'll go to the entity class. Here the entity class is enhanced. So here I have said entity. Now there's no data tag. There is a table tag which says that whatever is the class, please map it to a table named products. And then I have defined two queries. So whenever I say product.find all, please call this SQL query. Basically it's a JPA query or Jakarta persistence query. It's not a SQL query because it's using some variables, P for example. So it is similar to SQL queries, but it can take some arguments as well. For example, here ID is passed as an argument. And it can work on the objects or variables within Java. So here I have also used bean validation. So here ID is the name of the column which it should be mapped to. So this is what, and this will tell that this is an identifier, primary key, and this can be auto generated. So there is a strategy generation type identity. This means sequentially it will be generated. Then here some validations are there. My name cannot be null, and if it's null then throw these message. So through annotations I have all the validations. For example, size of the name should be 1 to 100 characters. So all these validations I can put here. Column, it's mapped to column called name. In the table, product. So this is how you will modify your entity class to map it to a table and column. Similarly, we have other validations. We have a constructor, right? And then we have defined all argument constructor. This is no argument constructor. So we have defined a constructor which is without the ID, because ID could be auto generated as well. So we have these three different kinds of constructors and getters and setters methods, which is like simple Java objects. And there is a toString method, there is a equals method, hash code method. All this we have defined or we have overridden. Okay, that's why we have this override annotation. So this is our entity class. Then we have other classes as well. Now we have a repository class. Repository class is all about creating the repository. Repository means it's a collection which is interfacing with the database. So basically all the database operations is taken care by the repository class. So here we have product JPA repository. Right, so here we have a persistent context. There will be a persistent.xml file which will have a unit name called catalog persistence unit or catalog PU. It will have an entity manager. This will take care of connection to the database. So all the connection handling is taken care by entity manager, and it will call the queries which we already defined. So this is the database logic, and it will return the result list. So this is our method find all products. Then find product by ID. It will call the SQL methods. That is what it is going to do. It is create product. Create product will also create and add a record in the database. Right. So this all logic is being defined here. Similarly, we will update the product. So this is all we have in the repository class. So we have also used here, so I have provided source code for in-memory pattern. So if we would have used array list, the repository would be similar. But here for fast retrieval, instead of array list, we can use a hash map also for catalog, because mostly we have to retrieve it with ID. So we have a hash map as well. So this is basic logic which is dealing with array list and hash maps. So nothing great about it. So you can either switch between in-memory repository or JPA repository. So there is a strategy pattern here. Basically there are two strategies, and you can annotate, you can use the annotation. I have defined annotations JPA. Here this annotation is defined. In memory, this is also defined here, another annotation. And this is retention policy. This is available at the runtime. And then there is a repository interface which provides all the repository classes. So this is programming to interface. Then we define repository type. And then important thing here is transactional annotation. This ensures that database transactions are taken care. Either the operation is performed fully, or if it is not able to complete due to some error, then it is rolled back. So this ensures transactions in the database which is associated. Now we have a resource class and service class, and then application configuration. So application configurations remains the same, nothing there, just the definition, product, REST application. And then we have a service class. Service class is again a bean which is application scoped, and here we are injecting product repository interface. Now if I use here in memory, this particular program will use in memory hash map. If I use here JPA, this will use the database. in this particular project, we are using Apache Derby database, which is a lightweight database written in Java. It's a relational database, and this is good for some sample applications like the one which I am showing you now. So now let me execute this particular web service so that we can see the execution of. I'll validate the POM first. So let me switch the project. This time I am in catalog project. So I've compiled the project. I'm running it now. So as you can see, this particular again the application is running. So now let me refresh this. Okay, now this is changed here. The project is called catalog. So I will use here catalog instead of MP e-commerce project. So now with database you have more records. So I have Apple iPhone, Samsung Galaxy, and various laptops, Sony, various other devices as well. So you have a lot of entries which is returned in the JSON. Now let me also run all commands. So we have a readme file which will describe this in detail. So the project structure is described, the architecture is described, database configuration is also described. So which is in this particular folder, which is within catalog, src. Then you have a folder which is called resources folder, and in the resources folder you have the persistence.xml. Right. So basically it will share what's the logging level, the database configuration, what is the persistent unit name, then the JDBC connection, what is the JDBC source, everything is defined, and this is the class which is used for generating the database table. So that's why this mapping is there. So basically persistent unit contains the mapping between the entity class and the database JDBC connection. Every time we will restart this will drop and create the tables. Right, so we should not drop and create all the time. We can just say update and create some other values. But yes, for demonstration purpose. Then I have a data initialization script which is load data.sql. This is also defined here in the configuration. And this is the load data, and which has various insert statement which will populate the database. We are using JDBC persistence, context and server in the format of JSON. Server in the format of JSON. So now I'll run the curl commands. So it becomes a little bit cumbersome to run the curl. So here, for example, So here there is a lot of details which is put in the readme file. The curl command, we can take it from our previous project and execute them. The only difference is now here we have the slight change in the path. So let me use that. So here is our curl command to, okay, let's say creating a product. So I'm opening. Okay, let's run these curl commands. So let's say we want to update a product. So we'll take this put command again. I will modify here first. Get log. And then I'll copy it. I'll make it more prominent here. So you see here the price is 1199.99. Let's see what's written. It was originally 999.99. Yeah, this is Apple iPhone 15. So now it is made 1199.99. Now I will update this. So the price should also get updated. So you see here 1199.99 is the update in the price. Okay, let me check if my voice is coming properly. So is my voice audible? I saw one comment from Dharmateja. Let me check the voice. Hold on a minute. Clean the product and project. It will clean the project and it will reinstall. Yeah, it should come because I think might be a temporary issue. So are you hearing me properly now? So please respond with yes if I am audible. There may be a lag. Okay, so yeah, in my computer I'm able to hear my voice properly. But yes, if you are facing problem, then I will share the recording also shortly, and we'll try to fix it. If some portions are not properly recorded, I will redo the session. So do not worry. Feel free to connect to me on this channel. Post some message queries. I'll revert back and I'll help you out if you are not getting any concept right. So now let's cover one more chapter. So yeah, the other curl commands, which is delete, can also be executed and tested. So if you want me to do it, I can do it shortly. Yeah, let's delete a product. So yes, when I run this particular curl command, I have to also modify this particular catalog. Otherwise it will complain that this particular path do not exist, which is what happened. Now I have deleted product number 1. So you see here product 1. Now if I refresh this particular page, the product 1 should get deleted because we ran the API. So documentation of API is very critical, because how to explain to your partners and co-developers that what kind of interfaces are exposed and what kind of data format is expected. So in MicroProfile, open API specification is very natively supported. So let me share you that particular chapter. So I'm reloading my IDE, and now as you can see, I'll be sharing the source code shortly, and I'll share you how to implement open API specification for your microservice. This was earlier called Swagger. Now it's part of open standards. It provides annotation using which you can create documentation automatically generated from your source code. So we discussed about creating a simple microservice, then we added RESTful APIs, we added logging interceptor, we added database. Now we will be adding the documentation, and then in later sessions I'll cover health check, fault tolerance, creating REST client, creating JWT based authentication for security, because when you call API, you should also verify whether the user is authorized to access the data. And then we will be covering observability, open tracing. We'll be using some tools like Jagger. So these are all the concepts which we'll be covering in microservices. So now coming to the source code of chapter 4. Here we have the catalog service, and in this catalog service we have the simple version, which is just using the array list. So here if you see so we have the same application, and in this particular application we have the product entity class, and then the difference is in resource class, which is about the HTTP interfaces, REST interfaces. So here we are using some annotations. So when we say tag, this is tagging the API. It is describing that this particular resource is called product resource. It is putting some description that this particular microservice provide CRUD operations for product. Then we have for each of the method this operation tag. It will give the summary of what this operation is all about, what is the response code for various returned outputs, and it will also describe what are the parameters in case the REST API is taking any parameters. So here you see there are more such details available for all of the methods. So operation tag, API response tag, these are the tags which is used for putting the documentation. So I have annotated all my methods. Now we should get the documentation automatically generated, and we will also get a web-based client for calling all the microservices endpoints. So all the REST APIs will be callable using browser because we will have a REST client. So now we don't need to use terminal. So some configurations needed as well. In addition to these annotation, we have one class which is called in this particular case webinf. Within resources we have webinf, metainf, and microprofile configuration dot properties. So we will have a configuration property which will say mp open api dot scan equal to true. So what this does is this tells the runtime to please scan through all the classes, and wherever you find the tag which is for open API specification, which are the tags which we just discussed, create an HTML documentation for all the methods which are annotated. So now I'll show you how this annotation is, so that you can also see how developer friendly it is and how much it will be helpful if during development you have such kind of documentation. So let's build this particular project. So I'll go to my project, which is within the folder code. Now we are into chapter 4. We are opening the project which is called catalog microservice, and here first we'll validate the POM. We will compile the Java code. Okay. Now compilation is also successful. We'll run this. Now I'm using Liberty Run, and this will just run it, and it will not be running it in debugger mode. So looks like it is being used already. Let me verify this. So if application is not available, then we'll not get the Swagger documentation. So looks like this is not yet updated. I'll stop the server. I will see the port should be available now. So if I again get the error, then I'll stop the Liberty server by giving a command. Okay, no worries. Now it should run. Only the debugger port was occupied. Okay, so here the port could not be bound. So let me stop the server. I will say mvn liberty stop. This will stop the Open Liberty server. Open Liberty server is a server which is from IBM, now open sourced. So it's based on WebSphere. Now let me try running this particular application. So now okay, still this particular port is occupied. So let's use some so let me check what is there. Okay, so lots of ports are running here. Let me go and say what's running in port 5050. So LSO of command will take port as well. Or let me check in this particular list what is the port 5050 being used for and what is the process ID which is occupying this port 5050. So let me open the readme file. So these details about troubleshooting the application is also described in the readme file. So I have documented all these steps in addition to the code execution steps. So let me come to that particular section which is about the troubleshooting, and in troubleshooting I have mentioned about how to deal with situation if the port is already occupied by some other application. Okay, so open API service not available, port is not there, should be there in some other readme files, maybe the readme file for chapter 2. Or chapter 3. So here we have the details about logging interceptor. Below that we will have the details about troubleshooting. So these are developer best practices, performance consideration, so running test execution, test cases. Let me just quickly find out this. So there is a command to kill a process which is taking the port. So yeah, LSO of -I, and then I have to give in colon 5050 as the port, because this is what is being occupied by some other application. So here we get this PID. So now I can just say kill 35 748, right? So now this particular process should be available and we should be able to run our application smoothly. So now we should not get that port conflict error. We are not getting that. So you see here the catalog service is running, and in the logs we will also see that all the features got included, which is JSON binding, JSON persistence, microprofile configuration, because we put the configuration about scanning the open API. Then we have this persistence as well, and RESTful web service as well. And our catalog and open API UI is also initialized. So I will show you what the open API UI looks like. So first, the metadata is generated out of all the annotations which we have given. So a YAML file will be created here which describes our APIs. So this is a machine readable documentation for the APIs which we have exposed for our microservice. Then we have a human friendly documentation as well. So which is in this particular URL, OpenAPI-UI. So you see here, this is the human friendly documentation. So here what we have is this endpoint API products, which lists all the products. And here we have an option, try it out as well. And when you execute it, it will call the API. And you see here, there is the JSON result, which is also included here. So this is the Swagger documentation. Very simple to generate using MicroProfile, because we just have to use some annotation. And now we don't have to deal with the curl. We can run everything. So even the post command can be executed here. And here I create a new product. Again, I'll say try it out. I get some JSON interface. So now I can put some new product. So for example, iPhone 16 Max. Let's say this is a new product, and I will put some description. And now if I say execute, it will execute this particular REST API. And let's see what's the result. Result says that this is 201 and it returns the new product. And we can validate this by calling this get all products, list all products. So I execute here. So now let's see if our new product is there. Yeah, you have here this new product, which is iPhone 16 Pro Max, yellow color, which we just created. So same way we can update this particular product as well. So to update the product, we go to put API and we can again say try it out. And in the JSON, we give the updates which we want to do. Now here I will say price is changed. Let's say it is $11.99. And now color, let's say this color we also changed. We say this is olive color. Now if I execute, okay, I have to give the ID as well. ID is 9 because that was required. And once it executes, the product should get updated, right? So now this is successful, and now if I run this get list all products, it should show now olive color and price is also updated here. So this is now very convenient to test your microservice, and also you can pass this documentation to any partner or colleague who want to use these APIs. And then we have these APIs as well, which is available with this very nice user interface. So I can also list the product by ID, and you get this product with ID 9. And we can also search the product. So I can say I can give some search term. Let's say Samsung. Now I execute this. It should list here the product which is having the particular search term which I gave. I can also give some price range. Let's say all the products which are 500 and below 1000. So okay, this is min price, so 500 here, and then we have 1000 as the upper cap. Let's see, do we have such products? Yeah, so we got products which are 699, 799 and 999. Alright, so this we can change also. So we say here now 900 and 2000. So this will give you more different products. So 900 and 2000 is all these products whose price are more than 999, 1299 and so on. So this is the search API. And then finally we will have update API. We also tested. Now the delete API is what we will test. And to test this, very simple now, you just have to provide the ID. So you say try it out, then this form will become active, and then you can put the ID which you want to delete, and now you execute. So now Apple iPhone olive color Pro Max 16 will not be there. So let's call this particular list all service method, list all products method, the products from ID 1 to ID 8 only. Now let's see the other method. If I go to the update method, okay, if I try to find this product ID 9, now it is not available in the database. So it should return here. It's saying its error response state 404, correct? So here product not found is 404. This is what we have described. Service under maintenance is 503. And we will try to update this particular product also. So let me execute this. Again, you should get some error. So again 404, response is found here. So this is real-time dynamic documentation where you can execute these commands in real time and it will return you the current data in the database. So this is a very convenient way to document and test any REST API, and this makes it very important specification for MicroProfile, because it's very critical for any microservices, because every microservice will expose a lot of services which needs to be consumed by different clients, partners and other microservices. So with this I'll end this session, and we'll cover more concepts in the next session in next few days, probably tomorrow. And then I'll also update this recording, edit it, make it very easy to understand, so that you can revise it and will update the source code. So thank you. For any queries, you feel free to post. I'll be there for few minutes, maybe 2-3 minutes more for any queries.